solve. Again, first step would be to isolate. In this case, how do I isolate the trig function? Add 1, divide by 3, right? So add 1, 3 tan squared equals 1, equals 1, divide by 3, tan squared equals 1/3. Right, now you got to take square root, right? Because it's squared. So when you take the square root, you have to say that the tangent of x equals plus or minus the square root of 1/3. Right? And that we could rationalize, right? That's like 1 over the square root of 3. So that is tan x equals plus or minus the square root of 3 over 3. And I'm going to write it in two. I'll write it as tan x equals the square root of 3 over 3. Tan x equals negative square root of 3 over 3. In fact, you know, in a way, it's almost easier to look at it like this: plus or minus 1 over the square root of 3. So now we've got to say, well, where would tangent equal the square root of 3 over 3, or 1 over the square root of 3? Well, tangent by definition, sine over cosine, right? So that must mean that the sine over the cosine is 1 over the square root of 3. You know, we know where these come from, right? It's got to be some combination of the square root of 3 over 2 and 1/2. So if you just write it like this, right? Divided by 2, divided by 2. You know, it's like saying, where does the sine equal 1/2 and the cosine equal the square root of 3 over 2? And actually, because it's plus or minus in all the different combinations, right? Because it could be plus or minus. I mean, looking at the unit circle, right? Here, like the sine is 1/2 and the cosine is root 3 over 2. So that would definitely be a place, pi over 6, right? The sine is 1/2 here, right? That would be 1/2 over negative square root of 3. That would give you a negative 1 over the square root of 3. That'll give you a negative over a negative. And that one will give you negative 1/2 over the square root of 3 over 2. So we know that's where tangent equals something with square root of 3, either 1 over the square root of 3 plus and minus. Now the way you write it is different because this one did not say from 0 to pi over 2. If it did, we could have just listed all of those values, right? In fact, this is going to be find all the values. And again, look at the unit circle. It's going to start here at pi over 6. And then it'll be at 7 pi over 6, right? But I'm going to keep going around, right? Then it'll be at pi. That would be 13 pi over 6, right? And just keep adding pi, and it'll keep going forever. This 5 pi over 6 plus pi, 11 pi over 6 plus pi. That's going to go on forever. Every multiple of pi around the circle, you get to another place that has the same value of tan. So the way you write that is like this. You would say, for the first angle where it's equal to the positive, you would say x equals pi over 6 plus n times pi. That'll give you all the adding pi halfway around the circle. And for the other one, it would be, that was 5 pi over 6. 5 pi over 6 plus n pi. Right, that will get us all of those angles, right? Because it didn't say just 0 to pi over 2. We've got to include that. You know, n is a integer. You know, it could be plus or minus, right? You could go around negative direction too. So if it doesn't say 0 to 2 pi, you're going to have some kind of a statement after that, like here's the angle plus n pi. If it was a sine or a cosine, since the period is 2 pi, it would be plus n times 2 pi. But this time it's just n times pi because it's tangent. Right? Yeah. X, both. X can be both of those. I could have just written a comma. This is the other one. So if it doesn't give you the 0 to 2 pi as the domain, then definitely put in some kind of a plus n pi plus 2n pi.